Hello and welcome to our Next in Line series of webinars. And today's topic is something really interesting. It flows through from the cloud webinar that we had done the last time. And this time the topic is really interesting, which I thought is very relevant too, which is PCI DSS and virtualization risk and controls. Now, again, if you want to get the full of it, also go through the webinar on the cloud that I had done, I think last time, and it's there on our YouTube channel. So do go through it. Now, at a glance, what we are going to do, I'm going to do a quick overview of what is virtualization all about, and then we'll get into the risk for virtualized environments, and towards the end, we'll go to the recommendations as to what you can do. And as we go ahead, feel free to type in your questions, and maybe as I'm doing this webinar or towards the end, or if time permits, that is towards the end, or I can always write back to you. So do write in. And again, I thank everyone for turning up in large numbers, and we are almost maxed out on our webinar. So thank you so much for signing and turning up. Thank you again. All right, so jumping right in, this is just a brief about me. I've been in this industry for like 25 years now, and I'm a PCI, QSA, CI, SSP, CISA. I've got my own company that is Vista InfoSec. We're primarily into consulting. So that's about me. And moving ahead, a few basics on virtualization. Now, virtualization, okay, a quick show of hands. You can see the hand icon on your GoToWebinar in a program window. You can just click on it if you agree. So a quick show of hands on how many people would be having virtualization in your organizations. Okay, don't feel shy. I'm not going to give out your names. It's not going to go to any vendor who's selling any sort of hardware, software. We are purely vendor neutral in that. Okay. So this is pretty good. Almost more than 80% hands have gone up. And okay, so virtualization has gone through almost the entire industry, as we can see. And so just to give a brief on that, before virtualization, as you may remember from the times when there was no virtualization, there would be a single OS. You have one hardware machine, and on that there is a single OS per machine. And again, the OS gets to use the entire hardware, all the software, all the CPU, all the memory, the entire network connection, the hard drive, everything is open for that particular OS that is running on the machine. There could be multiple applications running on it, which could then conflict with each other. There could be underutilized resources. Different issues were there. Plus, okay, now do not confuse a multi-boot machine, that in which you will be having multiple operating systems on your machine, and you can boot into each operating system separately. Now, but still remember, at any point of time, there's only one operating system that is active. So if you have Windows and Linux on that one machine, you don't end up running both at the same time. That is in a non-virtualized environment. Things change in a virtualized environment. Now, I put the name VMware over there, but there are many other players, but just because everybody recognizes VMware and most of them are using it. After virtualization, okay, you got hardware independence, you got the same CPU, memory, NIC cards, and hard drives, and at any point of time, you can have multiple operating system, multiple OS running on the same system, multiple operating applications working on separate operating systems. Now here they are not, here they are sharing the same hardware resources. So I can say that on one virtual machine, I can give 2 cores. On a different one, I can give another 4 cores. I can split up the memory. I can split up the hard drive. I can split up the NIC card utilizations. I can even have multiple IP addresses, even though my NIC card is the same for each of the operating systems working on the machine. So that's about it on that. But okay, on this thing, virtualization basics, again, there are 2 architectures when you're looking at virtualization. In hosted architecture, the VMware, not VMware, rather the virtualization system runs as an application. All right, so you have something like VMware workstation running on your machine, or a Hyper Hyper-V PC running on your machine, and so it has an operating system. On top of that, your virtualization system is running. But in a bare metal hypervisor architecture, which is most of what you get to see nowadays, it is very lean and mean. So there is no operating system like this. Straight away above the above the hardware, there is a virtualization layer, that is a hypervisor, and immediately on that you get a console for setting up your different virtual machines. You have a clustering software if you so wish so, and you can have multiple operating systems running. It doesn't need an underlying operating system as what you can see here in the hosted architecture. So there are two architectures with regards to virtualization itself. What does it look like? Now over here you have all the computational resources, all the storage. There is a virtual infrastructure that is running, and transparently to all the desktops they get to see, even though there could be just one hardware system, there could be on one hypervisor there could be maybe 10 odd operating systems running depending on the horsepower that is there on that particular virtual machine. And you can have one Windows 2000 running a web service, another running a database, Linux running another web server, another Linux running a DNS, and so on and on. So you can even have Lowell running on it. So you all mix and match is possible. Results depends on the horsepower that you have on the machine. That's about it. And what that results in is decreased cost and increased efficiencies and responsiveness. So you can cut down on the idle time. So at any point of time, if your database is not really running, needing as much horsepower, you can shift the CPU utilization to maybe this business app running over here on business on Windows XP. It is possible. You can just shift, mix and match as on the fly as you want. So application areas, again, there are different types of virtualization. I don't have time to get into that, but you can look it up if you wish. There is server virtualization, there is storage virtualization, network virtualization, infrastructure virtualization. You may have even heard of application virtualization. There is desktop virtualization. There are different, architectures even within virtualization that has come up. So you can look it up, but unfortunately I don't have the time. You can drop me a line if you have a query. I'll be putting up my email address towards the end. You can always write to me and I will most positively respond to you. Going ahead, again, as we had seen, different types of hypervisors. There is bare metal and hosted. You can see in bare metal there is VMware ESX, Microsoft Hyper-V, Citrix Zen Server. Directly the hardware, there is a hypervisor and the virtual machine is running on it. And this is what you may get to play at home. That is, you have a laptop, a souped up laptop. On that you have maybe Windows 10 or Windows 8 or Linux or something, and on that you load a hypervisor, which could be VMware Workstation or Microsoft Virtual PC again, or Sun VirtualBox. There are so many of them, and within that you can have various virtual machines. But again, this is like the hypervisor is an application on the OS. Over here you don't have an OS. That's in the bare metal virtualized setup. Again, in server virtualization, there are different vendors. There is VMware ESX, Citrix, Microsoft, Red Hat. Again, I'm not saying in decreasing order of preference or increasing order of preference or anything like that. I've just listed them out at random. So don't take this as an opinion from my side that VMware is the best or something. I'm not saying that. Now, what are the risks for the virtualized environment? Cutting to the core of it, again, do drop in your queries and I will respond to you, even on the fly if possible. What about the physical environment? Now, as it goes without saying, if you were with me so far, the physical environment security requirements in a virtualized environment is identical to what you see in a non-virtualized environment. So because the hardware platforms remains the same, what you've done is at a virtual level, you have segmented the hardware to increase efficiencies and better response times and better costings. But everything else remains the same, whether it's a private access key door, video cameras, armed security, multi-factor authentication, whatever is there, you still need the same key card access to each rack. Everything remains the same. Nothing changes with regards to virtualization or a non-virtualized infrastructure. Same attacks and vulnerabilities that exist. So we can move on from here. The hypervisor creates a new attack surface. Now, what do I mean by that? In a virtualized environment, what you get to see is that there is an underlying hypervisor which is actually running the whole show for you. So by default, it's got a new system running on your hardware, and that creates a new attack surface. That there is a new point of entry for a hacker or a virus or any sort of intrusion to enter into your system. And now, oh man. Okay. Now in this thing, with regards to the hypervisor, you get to see if there is any weaknesses in your hypervisor isolation technologies, access control, security hardening, everything else can get exploited, and somebody can get access to the individual VMs. Now understand, no matter how much you've secured your VM, in case your hypervisor gets compromised, all the VMs are by default gets contaminated or is open for any sort of unauthorized access. So again, access to the hypervisor should be restricted according to least privilege and need to know. And all the independent authorities, monitoring of authorities of activities should be enforced for with regards to the hypervisor, because understand, the hypervisor is a controlling factor of all your virtual machines. No matter how much you have isolated or hardened or whatever you have done your virtual machines, if the hypervisor fails or is compromised, everything else is up for grabs. Increased complexity. Now understand, on a virtualized infrastructure, you get an entirely new challenge with regards to designers. You get all sorts of new system and network that can happen through the virtualized infrastructure. There are, you may or may not have heard of it, there are virtual firewalls, virtual switching, virtual routing, all those things happen. There are virtual operating systems. So with regards to the complexity in design that has happened vis-a-vis a physical hardware setup, there is an entirely new set of threats which are unforeseen by the system designers earlier. So when you are planning a virtualized infrastructure, ensure that you get a good system designer who knows how virtualized platforms work. More than one function per system. Now, as you're aware that as far as PCI DSS is concerned, you cannot have more than one function per physical system. So you cannot have one system which is Active Directory and also the antivirus server at the same time, or there is a DNS system and it is also running some application server or a database server. You cannot have more than one physical system, one function per physical system that is there. So same thing applies to a virtual machine. Now understand, when a VM gets compromised, even a virtual machine, it could use the virtualized layer communication to launch attacks on other VMs on the same host. So understand, I cannot take the name of I've seen this happen actually. This is one of the best known hosting platforms in the world, and I had seen it myself. That is, one of the some critical VMs on their virtual servers got compromised, and that by default scrubbed out most of the other VMs on their virtualized platforms. So it is very well possible that some sort of a vulnerability in one of the virtualized VMs gets compromised to somebody else, to some other VM also. Mixing VMs or different trust levels. I think this is a no-brainer, but I'll still walk you through it. Just to increase efficiencies, it's very well possible that you may have some heavy-duty database running on one system, or maybe a few applications running on one system, which is used for internal testing or database sorting or stuff like that. And one of the system designers sees that, okay, I still have 20% capacity which can be used, so let me just use it for hosting a web server on that. That's a big no. You can't do that. Don't do that. If you've got a the virtual machine which is running the database is of course at a very high requires a very high trust level. It's very sensitive. So do not mix it with some other VM which has got a lower trust level. So in case the web facing the internet facing web server gets compromised, it's very well possible that somebody can tunnel through your compromised web server onto the database server. So do not have multiple trust levels on one hypervisor. So if you're going to keep all your DMZ applications, keep it on one hypervisor. Do not mix it on your card data environment hypervisor. So keep it separate. Keep it separate. Lack of separation of duties. Now, you may have heard of something called as a God syndrome. What it means for that is most of the administrators that's running feel themselves as guards of the entire virtualized scenario. And that's where separation of network administrator from the server administrator from the application administrator becomes very tantamount to you ensuring that your virtualized infrastructure doesn't get compromised. And again, ensure that there is efficient, adequate monitoring and enforcement. Again, what I mean by that monitoring and enforcement, I'll cover this later on. So stay with me. I can see some questions popping up, but don't worry, I'll be covering that going ahead. Now, there are dormant virtual machines. What I mean by that, understand VMs that are not active. So what can happen is that you have maybe multiple application servers, like messaging servers on your system, and you keep a few virtual machines dormant in the sense that only if I need, only if the load goes too much, then I'll start those particular virtual machines. But understand, those are still hosting sensitive data, authentication credentials, encryption keys, configuration information. Now, typically speaking, all the active virtual machines are protected by something like a firewall, something like an IPS and stuff like that. But what about those virtual machines that are stored away on your SAN drive, your storage access, storage area networks? They can even contain payment card data. What about the data in the VM's memory? See, when you pause a particular machine or take a snapshot of a particular machine, it even captures the data in the virtual machine's memory, which may also include unencrypted PAN data, that is unencrypted card data. Now, when that snapshot is taken, even that memory gets stored. So somebody having access to those dormant virtual machines can access all that sensitive data. Now, this can very well be like a possibly unchecked backdoor to the virtual environment. You may think that you have protected, you've got all the APTs and APT systems, firewalls, WAFs and all in place, but the virtual machine stored on the SAN drive. What about that? It flows through into a virtual image and the snapshots. Now, as a part of the DR strategy or a backup scenario, companies take snapshots of the virtual machines, and that is stored away at a DR site or on an external storage device to be pulled up in case of any downtime. And again, same thing as what we saw in the dormant virtual machine. This is much more sensitive because these actually get shipped to maybe a DR site, or could get you know put on a SAN drive or an external storage hard drive. Now, in case that is not secured, in case that is not protected from modification, what can happen is, let's assume you have made a DR scenario and somebody changes the snapshot by by putting in some malware, by putting in some antivirus, or removing the antivirus and stuff like that. So when you roll out those snapshots or roll out those virtual machine images, by default that vulnerability gets replicated across your organization. I've seen companies do that. What they do is that they create one benchmark snapshot of their scenario, of their setup, and when they want to roll out like 100 web servers, they just take that one snapshot and then replicate across various locations, then change the localized data like an IP address and system name and stuff like that, and it gets rolled out. Now, what if that particular web server got compromised? That VM got compromised. By default, all those 100 web servers would get compromised. Now, it works in a different way also. Now, what I mean by that, maybe you took a snapshot, and after that, maybe Microsoft or Apache released some very, very critical sensitive patches. You rolled it on the production, but that snapshot was never updated. Now, when you roll out that snapshot, when you roll out those VM images, by default, that unsecured web services platform gets rolled out across the enterprise. Is that a good scenario? Absolutely not. So just pay attention about that. This is something that I would like you to really focus on. That is immaturity of monitoring solutions. Now, virtualization increases the need for logging and monitoring because it's not just your server CPU login, log off, and all those things happening. There are multiple things that is now added to the scenario. There is virtual networks, there is virtual firewalls, virtual compliance systems. All those things are there. But what you need to ask is your SIEM, is your log management system capable of storing those counters as well? What about the traffic flowing between VMs on a virtual machine, which may or may not even hit your logging system? So that is something that you need to check. Maybe you need to write a new, plugin to ensure that that data also gets pulled in. but you need to get it done. But without taking this into consideration, do not proceed with your virtualization scenario. What about the management interfaces, host machines, virtual appliances, all those things? Are you getting the logging in place? More often than not, I've seen logging as the most ignored scenario that system designers ever take into consideration. So moving ahead, hang on, there is a good question that I see. Okay. Okay, he's asked a good question. Just to paraphrase what is asked, um, the question is, how do you secure those VM images and snapshots? Since I have just passed through this particular slide, I will take the question. So, okay, that is a very good question that has been asked. And what happens in this is, we always suggest that whenever a VM is updated, as a benchmark for the organization, keep a hash code of it. Keep a hash code of it for any unauthorized updates to that VM that may have happened. Maybe somebody swapped the VM. It's very well possible. So keep a hash image, keep a hash of the image, and ensure that those that the hash checks are done before it is loaded onto the production system. Secondly, you can even encrypt it, store it in a proper device so that nobody has got access to it. And last but not the least is, you know, there is, as you may be aware, there is errors of commission and errors of omission. So with the hash value, you have taken care of errors by commission. That is, somebody intentionally making some changes to it, or even unintentionally, that is. But what if you, as I said earlier, you have upgraded the production server, but you've not upgraded the snapshot. So when that snapshot gets rolled out, the rest of the infrastructure is at a lower infosec benchmark. So what I would suggest is that whenever have some sort of a good process in place, that whenever any, as a part of your vulnerability management system, as a part of your system management cycle, what can happen is whenever any sort of changes are done, you can even include this in your change management system. That is, whenever any sort of changes are done to production systems, the last thing that you do after the users are signed off is to take a snapshot, take a hash code, update the storage devices. That's the way that you can do it. I would also always suggest to encrypt it. The reason is, in case those VM images get stolen, so that all those credentials, all those unencrypted PAN or any sort of configurations, settings that may be there on the VM doesn't get leaked out to the outside world. Okay, moving ahead, the recommendations. Now there are quite a few recommendations. Of course, I cannot squeeze in all of them, but I'll try and be as practical as possible. So stay with me. Scope it out. I put double exclamation marks over there, and what it simply means is that, understand, when you are doing a non-virtualized system in place, and you are setting maybe a new payment gateway, or you're setting up a new data center or a DR, you'll be keeping a list of all the hardware assets in place. But with the virtualized scenario, everything changes. You now need to include in your asset listing your hypervisors. What is the workload on those hypervisors? How many hosts are there? How many networks have been configured? What about the management console? The physical site details for each of those components, who can see what is the primary function, what is the secondary function, who's the owner of each virtual machine, what traffic flows between the VMs, across VMs, or even across hypervisors. All those things needs to get mentioned as a part of your scoping mechanism. Otherwise, it's going to be hell to pay going on. You can even you even need to list out on which virtual machines, removable disk are allowed, not allowed, USBs are allowed, parallel serial ports, USBs are enabled. You need to have all these things defined out. And finally, last but not the least, is the types of segmentation that is there in place. How are the various components in the virtualized environment segmented out? Harden the hypervisor. Oh man, this is going to be tough. Hardening the hypervisor is an extremely tricky scenario. Of course, all the OEMs, they give you hardening checklist, as you may say that. But remember, each virtualized environment is unique. You may or may not even want to make all those changes that is recommended by the by the OEM. And understand, even in if it is a PCI DSS environment, even your hypervisor and management tools becomes a part of a PCI DSS scope. If you got one hypervisor with 20 virtual machines, but only two are a part of um, the PCI DSS scoping, now this entire scenario is very bad. The reason being, you should not have non-PCI DSS systems residing on the same hypervisor as PCI DSS scope devices. But let's assume you do have it. The entire system becomes a part of the scope. So ensure that you take that into consideration when you're scoping out, especially in a PCI DSS environment. Restrict the use of administrative access to defined endpoints, networks, and devices. So it shouldn't happen that anybody sitting anywhere should be able to access a hypervisor from no matter where they are. You should have multiple, security is always multiple links connecting together, adding to the overall security posture of the organization. So identify specific laptops. You may have digital certificates, all those things enabled. Now, as a part of PCI DSS, multi-factor authentication, if it is a remote access, is a must. It's not really a choice, it's a must. Ensure that all the changes are implemented and tested. So again, because understand, if one of the VMs is compromised, everybody gets compromised. Again, and hypervisor administrators do not have the ability to modify, delete, or disable. I think this is a no-brainer. Hypervisor audit logs. So the administrator should not be in a position. So for that, you ensure the next point. That is all the hypervisor logs to be sent immediately, if possible in real time, to a physically separate secured storage. So even if the administrator wants, is not in a position to do it, even if the hypervisor is compromised, the hacker is not in a position to erase the logs. Again, monitor the audit logs, separate duties for administrative functions, and again, verify what security controls the solution supports and what it doesn't. Understand, there are different providers for virtualization, but it is very well possible that some support X security controls and some don't support that particular controls. Now, I cannot get into details because I cannot be saying in an open system like this, in an open webinar like this, as to what security functions Microsoft supports and what security functions VMware support and who doesn't support what, because it's finally not a game of numbers that who supports how many functions. It depends on what you want. So make a list of what security controls that your organization is looking for, and whether the hypervisor that you're planning to buy or roll out supports those or not. Now, before we move any further, I'd like to cover one point. That is, when you're doing any sort of virtual VAPT, okay, a quick show of hands, how many organizations, how many of you, that is your organizations, actually do a VAPT in your organization? Okay, don't feel shy. Again, I'm not going to share the names, and my marketing team is not going to call you in case you're not doing it. So this is a knowledge sharing session. So don't worry. Okay. Okay, almost all of you. Okay, now how many of you have actually done a VAPT of your hypervisor? This will be an eye opener. Okay, not many. Okay, it's I appreciate your honesty though. I really appreciate your honesty, because it's very rare to see organizations who are actually doing a virtualization risk assessment, that is assessing the hypervisor. Because as we saw earlier, if the hypervisor gets compromised, all of the virtual machines and the services gets compromised. Okay, to let you know what should be covered in a virtualization risk assessment, what I would suggest is go to our website, that is vistainfosec.com. I'm sure you got the URL, and go under services, and you can see one service called as virtualization risk assessment, and over there you can see what all areas should technically be covered under a virtualization risk assessment. And if you have any queries, do feel free to write in, and I'll be more than happy to respond to you. Harden the virtual machine. Again, disable, remove all unnecessary interfaces, ports, devices. Goes without saying. Establish the limits so that if somebody initiates denial of service on one of the virtual machines, it should not hog up the entire configuration of your hypervisor, thereby shutting down the other virtual machines also. Ensure that, again, not just the hypervisor, but even the virtual machines are hardened. harden your individual machines and send your logs to separate secured storage area in real time as much as possible. Okay, that brings me to my end of my webinar. I'm running pretty strong. I'm almost all out of time, but okay, I can see a few queries. Rest assured, I'll be responding to you by mail. And these are the so far the webinars that has happened. It's all there on our YouTube channel. And this is what you are currently seeing, PCI DSS in the virtualized environment. And my next webinar is going to be on August 23rd. That is targeted attacks, spear phishing, and social engineering. As you're aware that in the PCI environment nowadays, there has been pretty sophisticated techniques for targeting the right people who can give access to hackers to precious card data, to precious sensitive data, and social engineering techniques. So we'll be covering this in the next webinar. I really hope that you would sign up. And as a change, in the next webinar that is coming up on August 23rd, we'll be taking into consideration multiple time zones. So you'll get a choice to select which time zone you actually want to sign up for. So this is for so many of our viewers who are, some sitting in the US, some sitting in London and stuff, and they want to be there for the webinar, but they are unable to because it's dead of the night for them. So again, I appreciate you guys signing up and giving us a suggestion, and as promised, we take that into consideration. So thank you so much, and there is a brief survey at the end. Do leave your comments, and these are my coordinates in case you do want to write into me with your queries or suggestions or feedback, and I would love to take it up. And again, this is our YouTube channel, youtube.com/c/Vista Infosec official. Do subscribe, and we've got lots of videos over there, lots of training sessions over there, and of course everything is free. So thank you again for being there, and I look forward to seeing you in the next webinar. Have a great day ahead. Thank you.